Welcome to Next Level Gentlemen, where we explore topics that sharpen your mind, elevate your thinking, and help you master the modern world. I'm your host, Callum Wren, and today we're kicking off a brand new series on one of the most fundamental and fascinating aspects of human knowledge: mathematics. Math surrounds us in ways we often take for granted, from the patterns in nature to the algorithms that run our favorite apps. Over the next few episodes, we'll uncover the hidden power of mathematics, exploring its deep connections to nature, technology, and our daily lives. But to appreciate where we are today, we need to understand where it all began. Here's a quick overview of what you can expect in this series. Today, we're exploring the history of mathematics, tracing its development from ancient civilizations to modern breakthroughs. Next week, mathematics in nature. We'll investigate the patterns and numbers that govern the world around us, from the spiral of a galaxy to the structure of a leaf. Future episodes. We'll look at how geometry shapes art and architecture, dive into the math behind cutting-edge technologies, and explore the future of this ever-evolving discipline. Math is much more than numbers and equations. It's a language, a philosophy, and a tool that has shaped human progress for thousands of years. So, without further ado, let's dive into the history of mathematics. Mathematics, like language, is a defining feature of human civilization. The first steps into mathematical thinking began thousands of years ago, when early humans needed to keep track of basic things like food, trade goods, or animals. The act of counting, using tally marks on bones or clay tablets, was the seed from which mathematics grew. Our first stop is ancient Mesopotamia, home to the Sumerians, Babylonians, and Assyrians. These civilizations were among the first to develop a complex system of numbers. The Babylonians, for example, used a base 60 number system, which is why we divide an hour into 60 minutes and a circle into 360 degrees. They were also early pioneers in geometry, which they used to calculate land boundaries and build structures. Their contributions to mathematics were practical, grounded in the needs of everyday life, measuring fields, constructing buildings, and tracking the movement of celestial bodies. Moving west to Egypt, we see another leap in mathematical thinking. Egyptian mathematics was largely geometry-based and was used to solve problems related to engineering and architecture. Their number system was primarily used to handle practical matters: taxes, trade, and the construction of monuments like the pyramids. For instance, they developed methods to calculate areas and volumes, which were crucial for building the pyramids with astonishing precision. From the Egyptian pyramids, we head to ancient Greece, where mathematics became more abstract and theoretical. The Greeks, particularly during the classical period, revolutionized math by introducing the idea of mathematical proof. Rather than just relying on observation and practical experience, they began to explore the idea of deductive reasoning, which is the foundation of modern mathematics. The towering figure here is Euclid, often called the father of geometry. His work, Elements, compiled all the known knowledge about geometry at the time and presented it in a clear, logical way. The idea of proving a statement through a series of logical steps became one of the cornerstones of mathematics, and Euclid's Elements remained the primary textbook on geometry for over 2,000 years. What's remarkable is that many of the concepts he developed are still taught in schools today. Another pivotal figure in Greek mathematics is Archimedes. His contributions were far-reaching, from his work in geometry to his foundational work in what would later become calculus. Archimedes is famous for his methods of calculating the area under curves and the volume of objects like spheres and cylinders. These early techniques were remarkably advanced for his time and laid the groundwork for later developments in mathematics. After the fall of the Roman Empire, much of the mathematical knowledge from the Greeks and Romans was preserved and expanded upon by scholars in the Islamic world. During the Islamic Golden Age, which spanned from the 8th to the 14th century, mathematics flourished, particularly in places like Baghdad, Cairo, and Cordoba. One of the most influential mathematicians from this era was Al-Khwarizmi, whose name gives us the term algorithm. Al-Khwarizmi wrote extensively on the Hindu-Arabic number system and is credited with popularizing its use in the Islamic world and, later, in Europe. More importantly, he is considered the father of algebra. His book Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala laid the foundation for algebraic thinking, providing a systematic method for solving linear and quadratic equations. This approach was far more flexible and powerful than the number systems and geometrical techniques that came before it. The Islamic mathematicians were also crucial in preserving and translating the works of the ancient Greeks, ensuring that the knowledge of Euclid, Archimedes, and others would survive into the Renaissance. Their translations would later spark the European mathematical revolution. The Renaissance, which spanned from the 14th to the 17th centuries, saw a renewed interest in mathematics, spurred in part by the rediscovery of classical texts. This period was marked by a dramatic expansion of mathematical knowledge, particularly in the fields of algebra, geometry, and number theory. One of the standout figures of this era is Fibonacci, an Italian mathematician best known for the Fibonacci sequence, a series of numbers that has fascinating connections to everything from art to biology. But Fibonacci's greatest contribution was perhaps his book Liber Abaci, which introduced the Hindu-Arabic number system to Europe. This decimal system, which includes the concept of zero, was far more efficient than the Roman numerals previously used in Europe and allowed for more complex calculations. Later in the 17th century, the work of René Descartes further transformed mathematics. Descartes developed analytic geometry, which allowed for the representation of geometric shapes through algebraic equations. His Cartesian coordinate system, which uses a grid to plot points and lines, is still used today in fields ranging from physics to computer graphics. Perhaps one of the most dramatic developments in the history of mathematics came with the creation of calculus, a branch of mathematics that deals with rates of change and the accumulation of quantities. Two men are credited with the independent discovery of calculus in the late 17th century: Isaac Newton and Gottfried Wilhelm Leibniz. Newton's development of calculus was largely motivated by his work in physics, particularly his laws of motion and gravity. He used calculus to describe the orbits of planets, the flow of fluids, and the behavior of light. Meanwhile, Leibniz approached calculus from a more abstract mathematical perspective, developing the notation that is still in use today. Despite their personal rivalry, the work of both men was revolutionary, allowing mathematicians and scientists to model the natural world with unprecedented precision. So where does that leave us today? Mathematics continues to evolve, building on the foundations laid by the great minds of the past. Today's mathematicians are tackling some of the most complex problems ever imagined, from understanding the nature of prime numbers to developing algorithms that power artificial intelligence. One of the most exciting areas of modern mathematics is quantum computing, which uses the principles of quantum mechanics to perform calculations at speeds far beyond traditional computers. These breakthroughs trace their origins to centuries of mathematical development, from the discovery of zero to the invention of algebra and calculus. Math is also the backbone of many scientific advancements. The fields of physics, engineering, economics, and biology rely on mathematical models to make sense of complex systems. Even social sciences, like psychology and sociology, increasingly use mathematical tools to analyze behavior and predict trends. That's a wrap on today's deep dive into the rich and fascinating history of mathematics. We've journeyed from the ancient civilizations of Mesopotamia and Egypt to the groundbreaking work of Newton and Leibniz. Along the way, we've seen how math has shaped not just science and technology, but philosophy, art, and even the way we think about the world. Next week, we'll continue our exploration with an episode on mathematics in nature. We'll look at how patterns, numbers, and shapes manifest in the natural world, from the spirals of galaxies to the structure of a sunflower. Thank you for joining me on Next Level, Gentlemen. Until next time, I'm Callum Wren, reminding you to keep leveling up and expanding your mind. Stay tuned, and I'll see you next week.